that. It's 4:05. We have 52 participants online. Gita, Danny, I'll go ahead and get started. Sounds great. Okay, well, good afternoon, everybody. It's so great to see new names, some familiar names. It's really exciting to see you all again for our second session of this ACE live presentations. Thank you for making the time to join us today. We have a great presentation by Danny on engineering today. So please, I hope you've gotten yourselves comfortable, have something to drink, because it's going to be a great session. And we look forward to answering your questions and just getting a chance to talk to you all again. As a courtesy again, my name is Jacob Leon. I am one of the team leaders. My school's over at San Diego High School. I'm also on the board. And again, on behalf of everybody on the ACE board, I'd like to thank you all for joining us today. I do have just a quick reminder, I got to do the housekeeping, so just bear with me on for today's presentation. Quick reminder that you're encouraged and more than welcome to turn on your camera so we can see your faces. If not, no pressure, but feel free to turn your camera on. Everybody knows that to stay muted until there's an opportunity to participate. And if, when possible, please use the raise hand function so that we know exactly who we may need to unmute and so that we can moderate the conversation a little bit later more efficiently. And as always, any kind of hellos or questions or comments, please use the chat function and go ahead and you can post them in that section right there. And so again, thanks so much, everybody. I'm going to go ahead and at this point turn it over to Danny so we can get started.
Okay. Hello, everybody. I'm going to jump and share my screen so you can see. Hopefully that works.
Good to go. Looks
good to go. Okay. Good afternoon, everybody. Thank you for joining the ACE group and for joining me for this presentation. This presentation is on civil engineering. A very significant or major aspect of engineering as it pertains to the construction field. As you can see, I am a licensed engineer, civil engineer. PE is for professional engineer, but I am a civil engineer. GE is a geotechnical engineer. It's another licensing, a specialty license. JD is also a lawyer, and a QSP is a qualified SWIP provider. I won't get too much into that. Also, I want to give special thanks to Sanj Malushti. Full disclosure, I've never met Sanj. I don't know him, but he's the one who originally created this PowerPoint presentation, and I modified it and added to it, so I don't want to be accused of plagiarism, so I'm giving him full credit for the original creation of this presentation. So, that being said, let's get started. A little bit about civil engineering. Let's see if I can, why is my... there you go. Okay. I'll use the page down function, I guess. Okay. So the objective of this presentation is to give you a little more awareness about civil engineering, talk about the various career paths that can be found within this field of civil engineering, an introduction to the role of a civil engineer, and a little bit of the understanding of how the design process works. Generally, some stats. There are over 200,000 civil engineers in the United States currently. Starting salaries are decent, ranging from 45 to 65,000. After 5 to 10 years, you can easily be earning up to and above 100,000. And with time, experience, and a good position, you can be well up into 150 to 200, and even well in advance or well above that, depending on the type of position you get and the company you get in with. Don't want to get too much. It's not just about the money. A lot of engineers get into it for many other reasons, but just so you understand, it is a good way to make a living. So civil engineers are responsible for the world's most inspiring buildings. I don't want to just read what's up there on the screen, but I will do a little bit of that, and I tend to get into a lot more pictures later on. So bridges, roads, definitely are some of the bigger projects that we get into. Obviously, a lot of the buildings that you see are all built by structural engineers, but most of the construction that is done involves civil engineering. Job responsibilities include the analysis, especially in the planning stage, of survey reports and maps. You also get involved in breaking down the construction costs and looking at and considering government regulations and environmental hazards. According to the American Society of Civil Engineers, which is commonly known as ASCE, a very large and prominent organization for civil engineers, the scope of the profession described as the design and maintenance of public works, such as roads, bridges, water, and energy systems, as well as public features like ports, railways, and airports. So that's sort of a very broad description of what civil engineers do. Engineering dates back centuries, one of the largest sectors in the engineering field. And by the engineering field, there's also mechanical, aeronautical, chemical. Let's see, those are the main mechanical. So those are the main other types of engineering fields you will get. But civil engineers are involved in these large projects at every step, from the beginning designs to the construction to the oversight when the project is complete. The Bureau of Labor Statistics projects a 6.3% employment growth for civil engineers between 2018 and 2028. In other words, an estimated 20,500 jobs opening up in this field. So that being said, it is a growing field. It's always been a growing field. There's always been a need for engineers because housing is always going to be needed. Infrastructure is always going to be needed. Improvements to both of those are going to be needed. So there's always work for engineers. And again, as I said, civil engineering is a very broad category of engineering. So it includes a number of subcategories. The first one being design civil engineering, then coastal engineering, structural engineering, architectural engineering, construction engineering, geotechnical engineering. And again, as I said before, I am a geotechnical engineer. It's a specialty license. Transportation engineering, and then environmental water resources engineering. So to become an engineer, just to step back a little bit, typically it does require a full 4-year degree at a qualified school to get a Bachelor of Science in engineering. And then typically you'll get experience and then have to take a licensing exam if you want to really get ahead as a civil engineer. Usually requires at least 2 years of experience under another licensed engineer. You'll then take your EIT exam, your engineering training exam, and then some further experience, and then you can get licensed as a PE. Somebody have a question? Okay. And then once you're licensed as a PE or professional engineer, 2 of these categories, structural and geotechnical, require additional specialty licenses. So design civil engineering. This is, I don't want to say it's the basic form, the most basic form of engineering, but it sort of is. Everybody, once you graduate as a civil engineer, you can do work in this field. Typically, basically incorporates the layout, design, and preparation of grading plans, improvement plans, and subdivision plans for residential and commercial development. Includes the study of drainage, topography, surveying, property line studies, and watersheds, and the study and analysis of materials and components used in building construction, such as concrete, wood, mortar, grout, and steel, for just a few examples. So, grading. Grading basically includes placing soils to create building pads. In this case, you can see the equipment is out there building a slope or recreating a slope because of the steepness of the bluffs. You have an excavator towards the bottom left and a small dozer in the back. In order to determine where those final grades are going to be, and the equipment operators need to know what to place fill to, that's where a civil engineer comes in one area. He designs what the final contours of the ground are going to be when a development is in process, or actually before the development is in process, and then those plans are followed by the operators, by the site surveyors, to enable them to build to the plans. So here you can see a subdivision. There's homes at the top, a finished graded slope. This before, in its original condition, was a steep canyon with hillsides. The soils had to be placed in such a way to create the building pads at the top. the slope coming down, and then you can see the concrete line drainage ditch partway down the slope. That's the design of that is also based on determining how much water is going to flow down these slopes, how much rainfall is going to occur, and where it's going to drain to. So all that comes into the arena of a design civil engineer. Also looking at materials, another significant aspect of a design civil engineer. The concrete is a man-made component of design. Concrete comes in different types of strengths, different type of mixes. It can be used for deep foundations, for building slab on grade floors, for building concrete flat work, for building walls. So all these types of concrete actually have different properties, different strengths, different amounts of cement in the mix. Concrete itself is actually a mixture of cement, aggregate, which is sand and gravel, and water. So when people say it's a cement truck, it's really not necessarily a cement truck, it's a concrete truck. Concrete is a mixture of cement, sand, and water. Cement is just one component. It's actually a very fine powder, but it creates the binding nature of concrete. Little side note there. So understanding how concrete is made, what needs to be in it, how it's going to perform is another significant aspect. You can see this is one of the largest continuous concrete pours that was done in the United States. It was a couple of years ago at a building up in Los Angeles, the LA Wilshire Grand Hotel. They poured concrete continuously for 18 straight hours, poured over 21,200 cubic yards of concrete, which is an enormous amount of concrete to be placed at one time. Concrete generates a lot of heat. When it's poured, actually, it's called the heat of hydration. The chemical reaction creates a lot of heat. So it takes a lot of control to get the concrete, when you're placing this large a mass of concrete, to behave properly. It has to dry properly. You see a bag of concrete when your dad's putting a fence post in, it looks simple. But when you're doing these large construction projects, it works much differently. Civil engineers also get into the construction inspection observation. Another large aspect of engineering is making sure that the construction is being done per the required codes, specifications, and the plans. So civil engineers also are required to make sure that the steel rebar, as you can see on the right side, this is a wall that's being built. Make sure that the steel is tied properly, make sure that it's spaced properly, it's the right size bars. And then when the concrete is being placed, it achieves the right strength through proper testing. So all of that goes into the role of a civil engineer as well. Coastal engineering, a very popular form of engineering out here in California, obviously because of our geographic location. So it's the branch of civil engineering that works in waterway environments, also involved in sustainable development, protection of coasts, oceans, ports, waterways, and wetlands, involved in wave run-up studies and coastal erosion rates. If you know or have heard of anybody or aware of anybody who owns a home on the bluffs in Encinitas or Carlsbad or Del Mar, Leucadia, Solana Beach, major problems out there with coastal erosion. As you've probably read in the paper, all the issues with the train tracks near the bluffs in Del Mar, the erosion is causing problems with how close they're getting to the tracks. So those are the types of works that coastal engineers get involved with. Typically working on ports, harbors, waterways, coastal structures, wetlands and sediment management, offshore facilities, and shore protection. Some examples of projects you could work on if you're involved in coastal engineering. Some of these airports, Czech Lapcock Airport in Hong Kong, and the Qatar Northfield Development in Qatar are some of the larger types of projects if you're going to work overseas. The airport was built out in the ocean by infilling with sediments and sands and soils brought from onshore areas. They built a cofferdam and then they just start filling until you're able to reach a grade that's above the water level. More locally, projects like this are what you'd be involved in: stairways, public access, storm drain outlets. You can see the one there in the middle. It's actually used to be back in the bluff. It's now fallen onto the beach. Again, this is from the bluffs in Carlsbad. You can see the erosion that's going on. What they do a lot in these areas is, if you look at the right side of the picture, that's actually a concrete or a shotcrete carved wall. It looks very much like the native bluff that's exposed just to the left of it, but the very right end is actually a shotcrete wall that's been architecturally carved and colored to match the existing environment. It stabilizes the bluff, protects it against erosion, protects the homes up above, and still looks like the natural environment. We do a lot of that in these areas. Again, public access stairways. If you're working on coastal projects in California, this is up in the Bay Area. Coastal Commission is very much interested in maintaining coastal access for everybody. So all projects have to provide a certain amount of coastal access to the public. Little project up in, this is up in Central California. You can see they're getting ready to place the shotcrete. The scaffolding that's up on the bluff was put there so they can build a wall. Another type of protection at the bottom of this slope you can see is what's called a rock revetment. It's basically large boulders, anywhere from 1 to 8-ton boulders that are stacked and placed, and it prevents the waves from eroding the toe of the bluff. Again, used very often throughout Southern, Central, and Northern California to help stabilize the toe of the bluff. And this is the same area as that previous picture. Let me just go back so you can see the scaffolding in place. Then the placing, this is my company did this project, placed a bunch of tiebacks, and then shotcreted the wall to stabilize it and protect the hotel at the top. So very interesting projects, coastal. They get very involved, and it's a very great, and again, with sea level rise, the issues that are coming up throughout the world, there's going to be ongoing issues with coastal areas. So again, a great potential for growth. Structural engineering is probably the most popular of the civil engineering areas. Most people want to get into structural engineering because they see it as the main focus of civil engineering. It's the design and analysis of structures to withstand loads and forces, such as dead and live loads, which is people and furnishings in a building, natural forces like gravity, wind and tornadoes, earthquakes, rain, snow and ice, waves, fluid pressure and temperature stresses, and then forces from equipment accidents, whether it's blasts, impact, weight, vibration, different types of thrust or operating torque from machinery. Structural engineers look at all these types of load factors in designing their structures. A little more in-depth understanding of the behavior of construction materials such as steel and concrete, timber and masonry, because they're using these products to build the structures. And they look at parameters such as stress, strain, ductility, durability, and jointability. Getting into some of the larger structures as a structural engineer, again, airports, bridges, nuclear power plants, a lot more involved in 3D analysis of the structures and the components if you're involved in structural engineering. So the scope of the design is much more complex. Again, a lot of analysis of the structures and how they interact with the natural environment, whether it's wind, earthquakes, ice and snow. All these factors have to be taken into account. So throughout the country, as the environmental factors differ throughout the country this large, each building has to be analyzed for those specific, for that specific location. In structural engineering, it's the most interesting, I don't say the most interesting, it's not what I do, but it's the area that most people who go into engineering want to pursue. Again, designing the major structures in the world, the major bridges, and the smaller bridges. Even something like this, the concrete foundations, the steel framing that spans between the foundations, all that needs to be designed by a structural engineer. The challenges typically involved or faced by structural engineers include safety, performance, and economy. As I mentioned, the site-specific conditions, unique owner requirements. A lot of times owners are specifying these very grand plans for what they want the building to look like, and trying to make that work and put it on paper is often very challenging. Just recently, you can see the two big stadiums that came into being, the Las Vegas stadium that everybody saw last night on Monday Night Football, if you're a fan, and the new LA stadium where the Chargers played on Sunday, if you're a fan. So two very unique buildings, and a lot of the structure was dictated by the requirements of the owner. International codes, if you're working in the States or doing design that will be used in other countries, you have to make sure that you're following the proper codes. Local materials and methods change even throughout the States. And then design, fabrication, and construction lead times. Oftentimes, if you're building something that requires steel beams, large steel beams, those are not something you just pull off the shelf. You have to go to a fabricator. It sometimes takes months to get some of these components fabricated. So you always have to factor that in into what's available and how long it'll take you to get them. Architectural engineering typically deals with the design, manufacturing of the architectural components. In other words, the non-structural components or systems of the building, mechanical, electrical, windows, cladding or siding, doors, ceilings, roofing, waterproofing. I don't get a whole lot into the architectural engineering because it's really more architecture than engineering. So when the architect does his presentation, you'll probably see a lot more information on this, but it does come into the aesthetics of the building versus the actual structural integrity in some cases, though some architects may argue with me on that. Construction engineering deals with the engineering and management issues associated with the construction of the building and the industrial structures. So it goes to the construction planning, the quality control, the field inspections, surveying, site safety is always a big one, and the construction tools and techniques that are used, we all also call it means and methods from the contractor standpoint. It addresses temporary facilities, hauling, rigging, and construction equipment. So basically the construction engineer is involved in the actual building process, not so much the design process of the building. So again, looking at different types of structures, making sure that the scheduling is done properly, that all the contractors are in line, that they know that have to interact with each other, that they're going to be able to complete the project on time and on budget. Again, for most owners, those are critical components of getting their project done. Many large stores, hotels, they have a set date that they have to be open because their revenue is based on opening on a certain date, and they're really relying on the construction engineer to make sure that schedules are met. So here's a good example of a construction of a schedule. It's called the Gantt chart, G-A-N-T-T. You may have seen these or worked with them if you've done a project already as a student. Basically lists all of the items that are to be done and then puts them on a table like this or a calendar so you can see which item occurs at what point in the construction process, if there are any conflicts between different aspects of the process that, or if one thing, what's called the critical path, if one thing has to be done before something else can start, those are called parts of the critical path. So oftentimes you can't start the framework of a house until the foundations are poured. So this is a much more complex project than that, but very often you'll see different parts of the project tied to other parts of the project that require their completion. Here's a little simpler version of a Gantt chart, not quite as complex a project, but you can see each aspect as you go down the chart. You get to near the end of one scope before the next one can start. Some scopes can run contemporaneously or side by side, whereas some scopes can't start till another one is partway completed. So understanding a Gantt chart or construction schedule is very important in being able to get a project completed. And then a budget. Every owner wants to know what the project is going to cost before he gets started. And once he gets started, he doesn't want to get surprised at the end to find out that the project cost $2 million more than he budgeted for, because that money has to come from somewhere. So planning out the budget is critically important if you're going to be, especially if you're going to be bidding on projects, laying out what the budget is going to be. And in some cases having as you can see down, there's a contingency towards the bottom under subtotal. Contingency is a what if fund that gets put in there at the end. Some 2% is pretty small for a contingency fund, but you always want to have a little bit of money in there to cover those things that happen that nobody expects or that somebody just forgot to include. So understanding the budget and how to put a budget together that an owner can understand and see and make sense of, again, very important for the construction engineer. Now we get to my favorite, geotechnical engineering. As I said before, geotechnical engineering does require a specialty license, as does structural. Geotechnical engineering is basically playing with dirt. That's what I always say. It's an understanding how the soil and earth materials perform for supporting foundations and pavements. The evaluation of soil properties for seismic effects, lateral earth pressure loading, slope stability, and involves the design and construction of shallow and deep foundations, earth retaining structures. I'm not sure what that is. Is everybody seeing that on my screen, those red lines? Okay, they're gone. Soil dynamics, earth dam embankments, soil improvement techniques, geosynthetics, excuse me, soil erosion, pavement subbases, excavation, and fill placement and compaction. Again, in California, for instance, where we have a lot of canyons, most of the residential developments you see are created by a combination of cutting off the top of the hillside and filling in the canyon, and then creating all the residential building pads. So other areas, you go back to the Midwest, where you have mostly flat farmlands. Large excavation fill placement is not very popular. But here in California, where we have the deep canyons, there's fill soils that are well over 100 feet deep and cuts of old hills that also are well over 100 feet. And then it gets balanced and creates the building pads. Soil engineers look at different soil parameters, including expansive soils, soil collapse, soil settlement, slope stability, both global and superficial, shear strength, and cohesion of the soils. Is how these soils perform is very much a function of what types of foundations you can then place on them, how they can be used to create a slope or backfill a wall or support a foundation. So all these factors come into play when you know when you need to design your structure. It all kind of starts back in history. I skipped a little on the foundation, but no one will ever know it. These are the two designers of the Leaning Tower of Pisa, and we know how that ended up. So skimping on the foundations and the soils that support the structure is never a good idea. It's very easy to take a shortcut because it's something that's not seen. Nobody sees it, it's buried. But when you're supporting a large structure with very heavy loads, it's critical. Otherwise, you can end up with something like this. This was a landslide that took down a whole row of houses. Obviously, these homes were no longer functional, no longer habitable, and they ended up tearing down a number of homes on the street. This is a site in China, actually, where they did some excavation, weren't aware of this building being so close to it. Well, they were the building being so close, but how the foundations for this building were built were too shallow, and when they dug next to it, the building came over. You can see, however, that the structural engineer did a very good job of designing this building because the building is still intact. It's just lying on its side. Walls and roadways. So these types of occurrences are very common throughout the country, very common throughout California, where you have improper placement of soils or construction, and problems can occur. And they create significant costs in trying to rehabilitate these structures. It usually costs more to fix a problem like this than it did to build it in the first place. And then in some cases, here's a project where a deep caisson is drilled next to this building. The building had undergone some settlement and tilting. So that steel cage is being dropped into a hole that was drilled. It'll then be filled with concrete. There was a row of these placed next to the building, and then the building is now supported on these deep caissons rather than just sitting on the ground because the ground was sinking. Transportation engineering involves the planning and design of public transportation projects, highways, airports, mass transit, surveying and planning of traffic needs, the layout of highways and airports, subway, light rail, monorail systems, and also negotiating rights of way and land acquisition. Very often when some of these public projects are being built, if you've driven up and down the 5 freeway lately, you can see all the improvements going on to the I-5 corridor. They've widened it in many areas, so all the land that was there sitting along the side of the road now has to be acquired by the government or by Caltrans, so they can now build the improvements they want to build. All that has to be studied to see if it's feasible, find out the cost, and then work with homeowners to get that land. Transportation engineering dealing with subway systems. Obviously, Canary Wharf is up in the Bay Area. It's the movement of people, basically, in its most basic form, whether it's on foot or by cars. Traffic circles have become very popular. This is obviously just a sketch of what you'd want it to look like in a nice area. Large clover leaves, getting cars off one main freeway onto another main freeway or highway. The size of the roads, the number of lanes that are required, the land acquisition, all that is part of the transportation engineer's responsibilities. And again, making sure we don't have this. Because if you don't do your studies properly, you end up with gridlock. And nobody wants to be sitting in that on the way home at 5 o'clock on a Friday. And just studying roadways, cracks in roadways, that make sure that the pavement is designed to the proper thickness, that it can support the traffic loads it's supposed to be designing, that it's supposed to be supporting, and isn't going to fall apart. This happened to this road before it ever even opened. And there was a slew of problems, but it sat there for years unopened because they couldn't drive on it. Water resource engineering. I won't get on my high horse, but this is another very important aspect of the world where we're at today and future of engineering. You study hydraulics, waterways, groundwater hydrology, water treatment, sewage treatment, storm drainage, watershed management, and treatment of hazardous waste. Applications to irrigation projects, water and sewage treatment plants, dams, canals, landfills, and soil site remediation projects. And there's a lot of contaminated sites that exist due to leaks from old mines, from gas stations, from all the industrial plants that have been around. So cleaning up the environment is, at least in my mind, a significant and very important role of the engineer moving forward. And it's going to be in the role of the civil engineers to be taking care of this. So I really want to, people who have an interest in the environment, this is a really great area to go into. Otherwise, we don't want our shores to end up looking like these areas. We don't want our bays to end up looking like this. Imperial Beach has had a slew of beach closures in recent years due to contamination coming up from south of the border. The cleanups that are required. Again, once it gets this dirty, it's very hard to clean it up. So we want to make sure that we take care of the environment. And again, I'm getting on my high horse, but it's something that I feel strongly about, that the role of the engineer is, the engineer is going to play a significant role moving forward in taking care of our environment, whether it's in this country or worldwide, because as I'm sure you all know and see in the news, these problems are not localized to just this area or this country, this state, but it's all over. One thing that also needs to be kept in mind is that the great thing about civil engineering is that there's a lot of interaction between these specialty areas. A structural engineer needs the soil parameters in order to design appropriate sized foundations. So he has to know what loads the ground can support before he can design his structure. If it's going to be a 2-story structure or 20-story structure, significant load differences. Transportation engineers need to know the soil parameters. They can design what the pavement section is going to be, because you get repetitive loading and they need to know what the ground can withstand for whether it's going to be 18-wheelers or just regular vehicular traffic, buses, trash trucks. All these things affect how the pavement's going to perform. Coastal engineers need to understand the soil types. I always get back to soil types to evaluate the erosion rates, and input from structural engineers to design a stabilization structure. So sandy soils that have a little cohesion will erode much faster on a bluff than soils that have enough of a silt and clay particle in it, which binds the particles together. If there's a certain cementation, it will last longer. And again, when the engineer is designing a wall or caissons or anchors to stabilize the coast, again, they need to know what those soils can support in terms of loads and pull-out loads. And structural engineers need to understand wave action from a coastal engineer to design a seawall or shoreline stabilization. That wave action pounds on the wall. He needs to know what that's going to entail. Construction engineers need to understand the types of structures to be built so they can evaluate the costs and the timeframes for scheduling, whether it's going to be a concrete structure, a concrete poured in place structure, a concrete tilt-up structure, a steel frame structure, a wood frame structure. So the construction engineers need to understand all those different types of structures so he can plan not only his schedule, but his cost estimate as well. And design civil engineers need to understand the underlying soil conditions at development so they can determine the most efficient ways to plan for cuts, fills, where the roadways are going to go, if there's going to be a water retention system. So they need to understand all those aspects before they can do a grading plan. So that being said, I really think civil engineering is a great field for a lot of people. It has a lot of varying areas, a lot of diversity in the types of structures and the types of components of engineering you can study. Here's a great example, a massive dam. The concrete structure is designed by a structural engineer for the most part. How it's founded and supported on the underlying granitic bedrock is determined by the soils engineer. The watershed behind it, how much water it's going to hold, where the water is going to come from, how much water is going to be stored behind this dam, what happens downstream of the dam, the roads that are right there that have to provide access for the dam. And then you get into the structure itself, the mechanical turbines that are in there, the pumps that are involved, all that becomes mechanical engineering, so not part of civil. But this is a great example of engineering itself, how far-flung and wide the types of works that are involved in a large project like this. So there's just so much diversity. The electrical wiring that goes into taking the energy that's created by this dam has to be taken to other parts of the country. So you have electrical components. So there's just so much involved. Studying the impacts on the environment of the watershed, retaining all that water, what happens if there's a breach in the dam, what's going to happen downstream. So that's one of the reasons why I love civil engineering. And that's why I really think it's got so much going for it. And, it's a lot of fun. And I get to play with dirt. I did soil engineering, so I got to play with dirt for many years of my career. So can never argue with that. So that being said, that is the end of my presentation, and I am happy to answer any questions. Hopefully I didn't talk too fast. I know I tend to, but hopefully everybody was not bored to death and able to understand my rants and raves.
Thank you so much, Danny. I appreciate you taking the time to go through this presentation and just showing all of our students and even other mentors and team leaders just the breadth of engineering, the engineering world out there. And so I think you did it just perfectly. At this point, I would love to turn it over and invite people who are online to either in the chat, provide commentary, ask any questions, or raise your hand. Geeta and I will be looking out for any hands being raised. But yeah, if anybody has not had a chance to go to Hoover Dam, I absolutely recommend going to visit this location. I think it's an exemplary example of some phenomenal civil engineering going on right there. Everything between the actual parking lot and the dam, you'll just be blown away. So I really hope everybody can make the chance to visit it.
So I get to go ahead.
Oh, I'm sorry. I was agreeing with Jacob. That is, it's a must see. It's so interesting. All the aspects of that entire dam. Good example, Danny. Thank you.
Yes, and I will say I did the tour many years ago. I was fortunate to do it before they closed a lot of the portions of the tour. I got to go down into the tunnels underneath. They closed that later on for a number of reasons, but it is an amazing structure to see from anywhere.
All right, I'm going through the chat. I don't see any hands raised. All right, here we go. We have John Funk. Go ahead and unmute yourself and go ahead and ask Danny your question.
We can't hear you, John.
Yeah, okay. So basically you talked about how you thought geotechnical engineering, I believe you said, was your favorite.
It's what I've done for 35 years, so yes.
Yeah, what brought you to that?
Well, I hate to be brutally honest, but it was when I came down to California, the first job I got when I came down here was with a geotechnical engineering firm. It was, with me, it was just fate. It wasn't necessarily a specific goal to be a soil engineer when I was in college. At the college level, you do study a wide variety of aspects of civil engineering. You'll take structural classes, you'll take surveying classes, you'll take foundation classes, you'll take concrete, you'll take wood timbers, you'll take soils. It was, one of those things where when I got here, I was lucky that I happened to find a job with a geotech engineering firm. It was a very large growth opportunity at the time. There was a lot of residential development going on. So I don't want to say there was anything specific that got me to become a geotech engineer, but I would say that I've enjoyed it every step of the way. I will say that a lot of what you get in school is really just the basics for what you're going to do later in your career. Like for me, for soils, a little bit, taking a 1 semester class in soils is basically just spoon feeding you little bits of information. What you learn out in the field working is really where you really get to learn most of what you want to know and do as a soil engineer. And I think the same thing with most other components of engineering. It was just, I like soils because so much of it is not sitting at a computer doing design. You're out in the field, you have to go out and touch, and in some cases taste the soil. We used to do that a lot to determine, the soil particle makeup. If you take a sample of soil and take a taste of it, you can taste the grit. You can tell if it's a silt, a sand, or a clay. Believe it or not, we used to do that quite a bit. But you have to go and dig a test pit, do a boring, watch the soils being placed. So for me, that was more interesting than sitting in a computer just running calculations.
Gotcha. Yeah. One more thing I want to ask. This might not be the best question for you since you said you kind of just happened to fall into fate with your job. But, obviously engineering, all engineering, but specifically civil, since that's where you're focused. It's a very, there's a very wide variety of jobs. How do you come to the conclusion what you want to do? Did you learn anything in your 35 years of, your job?
Well, the one thing I liked about civil And that's why I went into civil engineering, because I love the construction field. So that was why I went into civil engineering in the first place. I wanted to do anything with construction. At one point in my life, I wanted to be an architect, but I found I had lousy artistic skills, so I went to civil engineering. But I love being involved in construction, every aspect of construction, from trying to figure out what you're going to build, how you're going to build it, the problem solving, which is very much a part of civil engineering, understanding the components of the different types of materials, how it's all going to fit together. And I always have, still like a kid in a candy store when I go to a construction project and there's big equipment moving around, whether it's an excavators or drills or what have you. I've always just been fascinated by the construction aspect and seeing things go up and going to a site years down the road that you've been involved in the construction and seeing something that is now a built product and knowing that you were involved in that. So and construction, I would say you can be a laborer on the end of a shovel, or you can be the president of a company like Bechtel, and you're involved in construction. So there's just so many aspects that you can get involved in. So again, whether it's geotechnical, structural, environmental, all those aspects of engineering to me are fascinating.
Gotcha. Okay. Yeah, appreciate it. Okay. Also, shout out Hoover Dam. Been there. Freaking sick. Yeah, but that's about that. Yeah. Thanks.
Thanks, John. All right. Anybody else in the audience have a question for Danny?
Means I was either very complete or I bored them to death.
No, don't say that. So Danny, we do have a question in the chat for you. And the question from Shabazz is, so you majored in general civil engineering in college and then you were able to work for a geotechnical firm?
Yes, and again, I went to school a long time ago, so I only got a bachelor's of civil engineering. I didn't do a master's or a PhD. That is much more popular now for many engineering students, is to specialize at the college level in geotechnical or structural or one of the other aspects and get a master's. At the time, I found it was, for me personally, and this is just me personally, I found it was better for me just to go and work in the field. And at the time, it was, getting jobs was much easier than it is now. A lot of students stay and go through the master's program because they're not quite ready for a job. The licensing board has considered making a master's degree a requirement of getting a license. They haven't yet, but that has been considered by the licensing board. Whether they will make that change, I'm not sure if they will. But at the time, you get a degree in civil engineering, and then you have the choice either through your job or doing a master's degree in a specialty to focus in one area.
Great, Danny. Well, we have a couple more questions in the chat for you. And in case there are any other team leaders or mentors in the audience with engineering background, please don't be shy. Feel free to jump in and support Danny in any questions. So Danny, do you think a PhD is worth it?
I do. I think, especially now, I think having that level of specific knowledge in a field is definitely worthwhile. It's not required, and again, it really depends on the individual. I do think it's worth it, but I want to stress that even if you get a PhD, to make sure that you get enough field experience. I've seen too many PhD students go straight into sitting at a desk and never getting any good practical field experience, whether it's in structural or geotechnical or environmental. Learning in the field still beats everything. Mm-hmm. So either doing it as an apprentice while you're in school, or getting some kind of an apprenticeship while you're doing your master's and PhD, but getting enough field experience, I can't maximize enough. But yes, I think a PhD is worth it.
Great. And then if you could please clarify for Rachel a little bit more of the differences between architectural engineering and just general architecture.
I'm not sure I can answer that really. Architectural engineering tends to be a little bit more of a involved in the design stages versus architecture, which tends to be more focused on just the aesthetics or the cosmetic aspects of it. So if you're designing windows, siding, as an architect, and I hope I'm not going to offend any architects that may be out there, you typically are more concerned with just how it looks, how the shapes blend together, where the windows are going to be lined up on the south wall or the east wall, where they're going to get the most sun coming in. Whereas on the architectural engineering side, you're going to be looking at the strengths and design of those components, whether or not they have to be single pane or dual pane for the environment, the types of loads that may be placed on a type of siding, if it's climatic conditions or weather conditions. So it's a little more design. The art engineering side is always more in the strength and the ability to perform versus purely architecture, which is more involved with the aesthetics.
Okay. Well, for those who are interested in to get more information on that, please come back in 2 weeks since architecture is the next ACE presentation. And so
There you go.
an opportunity for everybody to learn a little bit more. We'll make sure to ask that presenter to maybe touch on it a bit more for everybody. Great. I do want to do a quick time check. We have about 5 minutes left before today's presentation ends. And so let's see, I want to make sure I've caught everybody here in terms of their questions. Geeta, sounds like there's a question I'm not seeing. Would you mind saying it out loud for us?
Itzel is asking, is it possible to work for an engineering firm without majoring in engineering, just considering how competitive it is to get into a university for engineering?
Yes, it is. And there are actually ways to become a licensed engineer without ever attending a four-year program, just based on experience. It's rarely done, but it is possible if you get enough experience and experience under a licensed engineer who will vouch for your experience, and you're smart enough to still pass the exam that's required. You can certainly do it. A lot of engineering firms, they do tend to lean towards hiring engineering students, so you will have that that mountain to get over, because there are a lot of engineering students out there looking for work as well, so you're going to be competing against them. But yes, it certainly is possible to work for an engineering firm. Oftentimes you can get a more of a non-technical role as a draftsperson. Doing computer-aided drafting is very, very big these days. You don't need to have an engineering degree for that. A lot of engineers don't want to do it. They, I don't want to say they see it as beneath them, but they do often think they're above that, so to speak. So working as a draftsperson, doing the drawings, computer-aided. Back when I started, we actually drew everything on paper with a pencil and eraser. All the drawings were actually hand generated. Now, obviously, none of that doesn't occur anymore. So there's a big need for that. People that can understand computer-aided design, people that are working for engineering firms doing lab testing, doing sampling of concrete, sampling of steel, or welding inspection. So there's a lot of aspects in the construction field that you can still work for an engineering firm that are construction related, and you still work your way up into a very positive position later on in life.
Yeah, no, great response. Thank you, Danny. And then there's also the whole, we at ACE always want to encourage, education in universities, all that, but I come from a military family as well, and the military also provides many, specifically engineering, many engineering opportunities, whether you go as an officer or enlisted. So lots of opportunities, like Danny was mentioning.
Yeah, and one thing I've always tried to push is, ACE is architecture, construction, engineering. It's not architecture engineering. So I always encourage students that are not necessarily geared towards a 4-year college degree, but are still looking for a good career. If you get involved with a construction firm, even if you're just starting off as a laborer, work yourself up into an operator, an equipment operator, doing HVAC, doing welding. There's so many aspects of just being a construction worker that even if you're not geared for a 4-year engineering or architecture program, there's so many places you can go in this field. And like I said, there's always going to be a need for infrastructure, for roads, highways, bridges, housing. Yes, we have slow periods in construction. There's always downtimes, but long term, there's always going to be a need for people. And right now, especially most contractors I talk to, they're looking for good workers. Very few people see that as a place to go, but it's a great place to go because you can do very well and not end up with $120,000 worth of college debt or $200,000 worth of college debt, which is where a lot of students come out at the end. So something to consider. You can get an apprenticeship program through AGC and start working right away.
Great.
Yeah, this is Tushan Patel. I'm with Whiting Turner Contracting Company. So to add on to that, there are plenty of trade school programs. If you're interested in a certain type of construction trade, like you're saying, steel, HVAC, there's trade schools that you can go to, all sorts of alternate means, to get into the actual field and be an actual, a craftsperson, we call them, right? You're
Yes.
a craftsperson. You work with your hands and actually physically put the work in, which is actually just trending. That group of people is going down. So it's actually a great opportunity for future people to get into.
Yeah, there's a big need for good, qualified, motivated workers to take over in those fields. Welders, you don't find too many welders anymore, but it's a great field to be in.
Thank you, Tushan. Thank you, Danny. We'll give the last question to Rice, and then I'm going to I'll do a couple of closing comments on some reminders for everybody. Danny, the last question is, just to clarify, if you were to get a 4-year degree in civil engineering, you could potentially proceed to work at any of the different types of specified engineering disciplines under civil engineering. Is that true?
That is correct, yes. Any of those different groups of engineering really just depends on where you go to work. You don't necessarily get, unless you're a geotech or a structural, you have to get a secondary license. Though I know a lot of structurals that didn't get the license, they just do the design. You can do up to a certain, I think it's up to 3 stories with just a civil license, without a structural license. I know a lot of geotechnical engineers that never got the license but still practice in soils. They're just licensed civil engineers. And all the other areas, it's just whatever job you get, that's where you end up. If you go work for an environmental engineering firm, you're an environmental engineer. If you go work for a transportation firm, you're a transportation engineer.
Yeah, thank you. Great, well, everybody, thank you so much for those questions, for the interaction. It was really exciting just to, introduce in civil engineering to those of you that may have not known more about it previously. I do want to remind everybody that on behalf of the other team leaders and mentors, that this is in addition to that we're doing these online Zoom sessions for those that may not have a current Zoom program at their school. That doesn't mean that you may not, or let me clarify. There may be some of you who are already participating in your specific school. That means your specific teacher or mentor has already been coordinating with you, throughout the fall semester. This is our catch-all series, just to make sure that ACE is still being presented and it's been interacted, we're interacting with you in some capacity. So again, my hat's off to those students and team leaders who still have a program right now, but there's a lot of teachers and mentors who don't have that capacity right now. So we're really, we're grateful for the opportunity to have these Zoom presentations for everybody else that may not have that opportunity. And then again, please stay tuned. This is gonna be, we'll have these every other Tuesday, and we have architecture on October 6th. We have structural engineering, followed by construction management, landscape architecture, mechanical engineering, and our last session will be December 15th, and just a catch-all session on sustainability and the future. So Gita, if there is anything else, I think we're ready to log off.
Yeah, that's it.
Great.
We'll see you all in 2 weeks.
See you in 2 weeks, everybody. Thank you so much.
Thank you, everybody.
Bye.
Thank you.
Adios. Bye.
Bye. Thank you. Bye.
Bye.